Manish Kumar Sinha. He has PhD from RWTH Aachen University, Germany, and presently he is serving at the State Technical University of Chhattisgarh. He has awarded with a Young Scientist Award at the year of 2017 and holds the gold medal from the State University, and has many recognized application under the national and international journals and conferences. His research interests center around the broad area of climate change implications, flood and drought management, modeling simulation, uh, RS and GIS in water resources application. He also has expertise in aerial surveying using UAV. He is actively involved in teaching and R&D activities. He serves as the principal investigator for the various projects under the State Water Resources Department, Raipur Municipal Corporation, TQ World Bank Project, and Rural Engineering Department, and presently running more than 10 projects in India. Today, he is going to brief us about the application part of this domain. We welcome you, sir. I think sir is left. Have you? Now I request you to please start the session.
Okay. So, thank you, madam, for the introduction. I think I missed it. First of all, I would like to thank you, Dr. Seema Chauhan, madam, who is coordinator for this FDP, and also all team members who is organizing this online faculty development program. And also sorry for bothering you all. So many times I am not able to receive calls from Seema madam.
It's okay.
So yeah, apart from our busy schedule, because it is winter and we have to finish everything, survey and all. So Seema madam, can I start?
Yes, definitely, sir. Okay. You are welcome. Thank you, sir.
Okay. So hello everyone. My name is Manish Sinha, and I think you have already know about me. I am presently working in CSVTU Bhilai, Chhattisgarh Swami Technical University Bhilai, as assistant professor. I am also a researcher in RWTH University, Germany, under DAD project. And most of the part we are working on remote sensing and GIS application in water resource management. We're also working in geomatics engineering, but our most of the projects is working on water resources applications. So today I'm going to give more. Hello.
Say, sir, you're audible.
Okay, sir. So today I'm going to deliver more on water resources side, but obviously you may correlate many things in your field also, because I have seen a lot of participants are coming from various disciplines. So don't worry. When I started speaking, I will try to cover all disciplines which participants involved here. Okay. So let me share my presentation right now. Okay. So is it visible, right?
Yes, sir.
So my lecture would be on this remote sensing and GIS application in water resource management. So today I tried to prepare this presentation for 5 case studies, including one small case study and our ongoing research project in University Bhilai. Okay. So I'll begin with each case study, and at the end I will try to project the results, and what is the application of this remote sensing data. So I think this FDP started on 23rd, and this is 26th. So you all have mostly known about this remote sensing products, that is DTM, DSM, digital elevation models, satellite imagery, right? So I try to project how you can utilize those data in your water resources applications. So our first case study was on Raipur city. It is a capital city of Chhattisgarh state in just north in semi-arid region. So this case study was on monthly rainfall runoff simulation, calibration, and validation of an urban watershed using HEC HMS. Okay. So the idea behind performing those study, especially in Raipur, in cities like Raipur, Raipur city is flat region. So when terms come flooding, everyone thought, okay, there is no hill, no valley. How the flood will come in Raipur? So it is a lack of infrastructure of urban stormwater management and sewer system. This is the problem in Raipur city, and it was addressed by Ms. Sunita Narayan, who is a Padma Shri and a writer of a book, Why Urban India Floods. So she had attributed Raipur city also and addressed in her book that Raipur city floods due to lack of sewerage, pondage, and I will show you how the land use of Raipur is being changed. So when the terms come land use, everyone nowadays think about satellite. Okay, in which satellite data we can occupy those images and how we can process it. So especially in Raipur city, you can see at the blue part at the right, there are a lot of ponds. In 1901 or 1902, there was 200 ponds in Raipur city. Now it's becoming only 64 or 65. So think, if you are replenishing ponds from a city and you are encroaching from that urban land use, you are keeping a very small linkage between this river, natural drainage system and your land use. So if you are reducing your uh, water supply and water distribution infrastructure system, obviously you are going to pay for it. So Raipur city is severely impacted by urban floods. It is flash flooding, and we tried to model it a little bit. So this is the Raipur urban growth population since from 1901 to 2041. So 2000 until 2011, it was a data from Census of India, and 2021, 31, and 41 is the projected data. At the bottom, you can see this is the imagery from our Indian satellite IIRS 1, and this is list 3 image, right? So we procure image for 1991, 99, 2009, and 14 from Indian satellite, and we tried to prepare this land use. So the color changing is actually the built up area. It's representing a built up area in 1991. Pink is 1999, blue is for 2009, and yellow is for 2014. And you can see the dynamics. So from the center of city towards the periphery, it is growing. So there was a lot of question arises how we can manage it and why it has been done so. So Raipur city is located just in the bank of Harun River. Okay, and one more thing that I'm going to give you a lot of details about Raipur because all of our 5 projects is related to this study area. So for particular this one, you'll be receiving a lot of information, and please keep in your mind so that at the next case studies you will be able to correlate it. So the problem was the informal growth of land use, and we wanted to track it. So we did a lot of analysis. In your past presentations, you will be able to know about this remote sensing imagery of list 3, panchromatic, TM data, thematic mapper, ETM data, okay, spot satellite data. This one is the most beautiful and very precious data we are having from 1965, where we were not having any satellite on the globe, especially for Earth resource management and modeling. So this was the image captured by a plane at the time of World War II by German aircraft. So when I was studying my PhD in Germany, I tried to collect this data. This is the image of Raipur city. That the circle marked is Raipur city. And I will show you the next figure. Now this is our study area. I will talk about this later. Okay. I will show you. I will show you later. So at that time in 1965, Raipur is like a very small village. Even it's not a town, very small village. The area is marked nearly up around 800 hectares or 900 hectares. That's it. There was nothing in 1965. But once they started growing, it started tremendously without any planning. Even in all around India, the small cities always started without planning, and the people suffered at later stage. This is our study area map. So we have this location. You can Google it. It's simple. The major issue is the population density. It is 66,000 per square kilometer people index. So this area of study is under consideration of 300 square kilometers, and the climate is dry subhumid. Is normal temperature 46 for India. Average annual rainfall is nearly about 1089. We used to take it 1100. Normal soil, clay, sand, silt, and topography. Topography is fully flat. There is no such hills around it. If you Google the slope of this Raipur city, the slope will never go beyond 12 degrees. If you are calculating in height of the degrees, okay. So this particular slide is from one of my student who is working on HEC HMS model to simulate this runoff calculation in Raipur city. So she procured imageries in 1989, 2000, 2010, and 2015 from LANDSAT data. This OLI sensor 8 and the rest of the SLC sensors. And she has used ArcMap to generate those land use classes. And method used was maximum likelihood and supervised classification. So this was the methodology. I'm skipping it. I will mostly focus on the results. So these are the results. So this was the first result that she got. So she did land use classification for 1989, 10, 2000, and 2015. So now you can see the growth of built up area. The red patch is a built up area. So in 1989 it was very small. In 2000 it's growing. 2010 is almost connected to a city Bhilai. There is a city Bhilai, and this is the northern Raipur of industrial area. So now see the industrial area is quite grown. Okay.
Sir, the slide is not changed. It is still the salient features of LULC change.
Is it still there?
No.
No.
No. It's okay. It is moving.
Yeah, because I'm showing land use land cover images. Is that
Yes,
okay?
slide number 12.
Yes. There could be a technical lag on behalf of your ma'am. So you wait for a time. So you may continue, sir.
Okay. No problem. So this was the beauty of your satellite imageries, right? So our discussion basically today is on this, how we can use those satellite data. And obviously satellite data contains two things, imageries and DMs. So in water resources application, we are mostly focused on DMs, but still we need a lot of information about satellite and historical imageries. So here we would be able to know from 1989 to 2015 what was the change. We are still working on it, and we utilize those imagery for preparing those hydrological soil classification and curve number. Okay, so I will not go deep in the core of this methodology because it's for water sources, but we utilize those imageries to calculate a curve number. Curve number is a factor which is essential to calculate runoff in the basin. Okay, so we perform one modeling in HEC HMS. You can see it. So those are curve number maps, which is made for input for this hydrological modeling in HEC HMS. Let's skip this one. We also procured a DM of 10 meter resolution from Cartosat 1A. You can also buy it. It's a very cost-effective price available in India. Okay. So this is a DM. You can also download it for free. I think you already know about free sources, SRTM, Master, Alos Pulsar. So this one is from Cartosat, and this is a part of a Kharun River, and we try to delineate our study area in this. So we put 2 points, inlet and outlet, and we performed watershed analysis. This is called D8 method. If you Google it, and when I provide my slides, you will be able to see there is a D8 method and there is a description for it. So D8 method used for calculation of slopes from DM, flow accumulation, flow direction, stream links, and later you will able to delineate your catchment based upon this data. Okay, so those are the intermediate steps for doing it. And now you can see the red lines are river lines. So in this river lines, we had two gauging stations at the inlet of city and at the outlet of city. So based upon those two stations, we delineated our study area. So now our delineated area is came with 47 subcatchments. Okay, and there's subbasin files and river files. Those are again input for HEC. Now your GIS part will come. So at the remote sensing, we always procure the data. Maybe it's free also, and we use it for our GIS analysis. So this is the linkage between remote sensing and GIS in water resources. So in this map, you can see there are a lot of reservoirs throughout the river. This is the main river of Kharun. This is Raipur city at the right side. We had 8 gauging station, rain gauge stations, and 2 discharge measuring stations. So for simulating this, we create some synthetic rainfall from historical data, and we try to run this for 4 different years. You can see this. If you are hydrologist or water sources, you can see this thesis polygon maps for this all 8 rain gauge stations. And after simulation, we got some results. At the top, you can see the rainfall depth. At the bottom, you can see that stream flow discharge. So just matching. As we are running it for 1 year, there is no such major lag you can see in the graph, but it was okay to run it, and we got some results also. And obviously, it is HEC HMS hydrological modeling system. One has to calibrate it. So we calibrated and we validated those results also with some modeling coefficients, which is R2 and NSE, cyclic coefficient. So we again calibrated, and now this was the result, and this was conveniently utilized by this water resources department. So this project was given to us from WRD Raipur to just check the balance of water availability in Kharun River for agriculture, industrial purposes. So this is one application you can use to model any urban or a rural catchment using this DM and satellite imagery. Obviously, satellite imagery is not necessarily used for you, but we are running this 4 different models: 1989, 2000, 2010, and 2015. That's why we use this land use land cover analysis as input of CN, because CN is the calibration parameter for us. So we use this. Those are the results. So this work is done by a few of my students from 1972 to 2015, because in 1972 you'll be getting only first land use in 1972. There was one satellite called Landsat 1, which was launched in 1972, and it started giving up imagery from December 1972. So at that time, the temporal resolution was quite less. I think you know the temporal resolution. Temporal resolution is revisit time of satellite, that how often the satellite take image for a particular point in Earth, right? So in 1972 to 2015, we did a lot of analysis, and we came to conclusion that the runoff trend and urban land use in terms of built up is changing in the same way. And you can see in the graph, the both graph is overlapping each other instead of rainfall. Rainfall, anyway, rainfall is changing, is going to less high. In Raipur city, it is lessing, it's declining trend. But you can see that because of urban land use, the runoff has always been increasing. This was one small project in our department, and right now this forecasting land use land cover change using Monte-Carlo MLP techniques, machine learning techniques, is also done by one of my students, research scholar, and we are just mid of this project. We are not finished it, so I would like to show you only some results. It's not whole project, it's just some result. So again, we are using that same imagery of Landsat. You can see here 1988, 98, 2008, 2018. So we have 30 years of decade here to analyze our land use. So for particular forecasting or projecting some land use, you need to let your system understand how it's been changing. So you have to give something like training. So if you are a mathematician or engineering background, you know about this machine learning. Okay. So in machine learning, you can use ANN. Okay. You can use genetic algorithms. There are a lot of mathematical equations available which you can use for prediction. So here we are using Monte-Carlo simulation, multiple simulations. So for this particular study area, we prepared 2 models, because we had this 4 land use from 1998, 88, 98, 2008 or 2018. So each has 10 years of decadal change. So we prepared 2 models called 10-year model and 20-year model from 1998 to 2008, from 1988 to 2008. And we validate this result from this forecasted result in 2018. and then we projected for 2035 because it was the need of Department of Municipal Corporation. So they have asked us to calculate predicted land use so that they can modify their stormwater and sewer system. So in the third case study, you will be able to see that also. So this is our 10-year land use land cover classification, and you can do it. I think in 3 or 4 days of learning this remote sensing and GIS, you can easily do it. Okay. So this is done in ArcGIS, and we classify those imagery in 6 classes: agriculture, open soil. Open soil means the part of land which is not being used. Built-up area, forest. Forest is likely to be gardens. Vegetation is like a shrubs and water body. Because in Raipur city there are a lot of ponds. So we did for analysis for 6 classes for this 10-year land use, and we project this for 2018. And when we compare it for our old 2018 analyzed data, we found nearly okay results. So we project this for 35 also. So this is 20-year model. So first was 10-year and second is 20-year model. And here you can see the projected 2035 land use. So in 10-year model it was not okay, but in 20-year model the results are quite good, validated in the field also. And now it is being used by Raipur Municipal Corporation to felicitate future stormwater calculation, stormwater management capabilities in Raipur area. So this was a small work on remote sensing side. Okay. Now the third project was done by one of my student, MTech student, identification of urban heat Iceland effect in Raipur city using thermal band of LANDSAT data. So we procured or downloaded a lot of LANDSAT data for Raipur city. So all project is anyway connecting to each other. First was to analyze hydrological balance in the city, and department also asked us to calculate some hydrological parameters. So that is another thing. And the second was to project land use. And the projection is land use being used by Raipur Municipal Corporation for designing stormwater facilities. And you can see in the fourth case study here. So here, I think urban heat Iceland is not new for all of you, because in later presentations, I asked Ms. Preeti Madam that, so she told me no, they have known about it, so I will not explain this. What is urban heat Iceland? It is basically heat of that land use. If you see from the satellite, you can track it 1 or 2 meters below, above Earth's surface. Okay, so you'll be getting heat data. The same will be utilized by our students to generate heat maps. So they have produced 4 maps for land surface after land surface temperature: NDVI, NDVI, and NDWI. So NDVI is normal differentiative vegetative index, NDVI is building index, or WI and water index. So computation of these indexes is the reason of how the land surface temperature is changing in Raipur city. Because when we analyze our rainfall data, when we hydrological modeling Raipur city, when we analyze it, we have been seen that rainfall is not changing because of climate condition of the sea-ocean interaction. It is because of local weather phenomena. So we try to investigate it using this LANDSAT data. This was the study area, and yeah, this is the sensor. So in remote sensing, you can see there are a lot of sensor, and before using it, you must know which sensor has which band that give you exact temperature data. So in 1998, we used thematic mapper. In 2000, we used ETM. In 2008, TM, and in 2018, OLI, that operational land imager, and thermal infrared sensor. And we also procure few data from IGKV Raipur and Indira Gandhi Krishi Vishwavidyalaya. So they have this operational, fully automatic rain gauge station installed in their institution. So we procure those data and we will analyze it with our land surface temperature change. This was the methodology. So I'll skip it. Here, this was the result of analysis. So this is the land use that I have already shown you, that built up area is growing. When we see the built-up area is growing, what about the peri-urban and rural areas? So this study is totally focused on how the land surface changing, temperature is changing in built-up area, mostly core urban and peri-urban area. So for that, we design those land surface temperature maps. You can see LST for January, May and September. So in January, the land surface temperature is quite normal. It's winter season. In May, it's too high. In September, it is a post-monsoon, something like monsoon and post-monsoon period, and you can able to differentiate, correlate it. In January, see, in 2019, the temperature is increasing. It is red. It is nearly 40 degree all around time. So this is a kind of images you can also generate in your projects also. Okay, so the reason why I am showing this images is because you can generate it for your projects. This is the cross-section profile of LST, land surface temperature. This is also one of the good application of remote sensing. So if you have a raster data, you can track each pixels and value of each pixel. So we had this land surface temperature of January 2019 and we analyze it. What happening in the city, the BB cross section is for urban area and the AA section is for rural or peri-urban area. So you can see that the temperature change. In rural it is declining, but in urban it's gaining the slope. So this was the reason why inside the city there was a lot of rain and outside it was less. Because when the urban heat island effect is placed in a city, the city temperature is been changing and growing tremendously high. So when temperature change, the hot air moves upside. Okay. So when there is a cloud of monsoon, it will automatically come to the city center and it'll start raining. This was the reason why it's always been raining inside the city, even in Hyderabad, Bangalore, Pune, Mumbai. Mumbai has a different reason also because it is near to the coast. But cities like mid of geography is always being affected by this phenomena. And there is also a cause that rainfall always started either in the morning, either in the late noon. It was very less often happening in the afternoon. So we are still analyzing those data. So this is the description how it's been changing. So you will be getting this PPT. You can correlate those data with your understanding. So this is normalized difference built up index. So how built up index is changing? Obviously, if the building is index is changing, that urban built up, your built up index is also changing. So you can see in September in 2018 image, there is a huge so there is a huge change in land use and there is a huge change in temperature also. Or this is the error actually. This is because of cloud. So my student is not able to remove that. So he picked that picture here. This should be removed. Similarly, this is the vegetative index. So vegetative index here is represents how speed and that urban area increasing and that vegetative and forest areas decreasing in the city. Similarly, water. So those indexes were be utilized to correlate how LST is being changing in Raipur city. So those are the correlation graphs and correlation powers that okay, this is changing okay or not changing. So this is the kind of analysis that we had done, and we also analyzed our pre-monsoon, post-monsoon, and monsoon rainfall to justify our LST outputs, that how it's been changing and what is the impact on rainfall. You cannot directly correlate your LST with rainfall, right? Never do that. But in certain analysis and certain evidence, you can say, okay, because of this temperature, your rainfall pattern is changing. Because Raipur city is just center of India, almost center. It's far away from that coast. So we can directly correlate it. But if you are in a coast, the LST behavior is quite different there. So keep in mind that how is it changing. So this was the project. So we had our fourth project on this modeling 1D 2D hydrodynamic SWM model to mitigate urban flooding and prioritize flood prone area. This was again done by one of my student who is working in PC swim model. Okay, Just a minute. Yeah. So before going to start this, first I would like to give a brief introduction why we had done this. Because in the Raipur city, we are continuously increasing our land use. Okay, especially for built up. And what happening is built up is changing. See this image. In the first image, there is a natural ground cover. So we have free infiltration, free runoff. Now in the second, impervious surface increases to 10 to 20%, 10 to 20%, and your infiltration is going to be less. Runoff is increasing. In the same way, 30 to 50 impervious surface increased, your infiltration is less, but your runoff is increasing. So runoff was 10, 20, 30, 55 as imperviousness is changing. This is a location of study area. So we was trying to design whole Raipur city in our PCC model, but because lack of that infrastructure facility, we only design southeast area of Raipur. Okay, so southeast area of Raipur we took nearly about 13 square kilometer to check as a pilot study area, because this study need a lot of money and we didn't had it. So we asked the department, so they told us, okay, so do only this pilot study, and based upon that, we will try to ask government to make it in a larger scale. So we use this data, DM resolution, 12.5 meters, is not 12, it's 12.5 meter raster image, 12 meter, 10 meter raster image. So 12.5 meter data is been downloaded from Alaska facility. It is a Japanese satellite, and 10 meter resolution is from our Indian cartosat. So the reason behind 10 meter resolution cartosat data is to delineate cross section of canals or natural streams in Raipur city. Okay, and we also did DGPA survey inside the city to take the cross section of natural drain. Basically, it's called Nala. Its local language is called Nala, and obviously cross section of open storm water drains. That's called Nali. I think all over India are here. So Nala and Nali, there is not so much difference. One is big, one is small, but the small one is having this concrete bed. So we did survey. We again delineate land use data, but you can see here the land use is quite different than the land use previously I used. Okay, I will show you. See that 1965 image I show you from 20th May, and now in 20th May 2017, the scenario is being changed. The city is growing all around over. So the red boundary shows that only study area we have considered for simulating urban storm water facility in Raipur. And so we had two scenarios, pre-development and post-development. What was before and what was after that, after urban goes. So the both, we design our models based upon DM availability. So the left one is from 12.5 and right one is from 10 meter. So in the left side, we have already 3 catchments and only 3 or 4 drains. But at the right side, at the same time, we have a lot of subcatchments, small subcatchment and small drains of urban stormwater flooding for 3 levels, like primary, secondary and tertiary. So up to 3 levels we have designed it to simulate flooding. The reason is because of to compute lag time. At the first photograph at the left side is a pre-development scenario. The lag time of a water flowing from top end of the catchment from the outlet is quite high. Okay, here it's been changing all around just because of shape and size of a catchment, and you will see that the data. So this is a satellite image we procured. This is list 4 image, and this is you can also get it free also, and few of list 4 images already available in Bhuvan website. You can download it from there. DM also you can download. 12.5 meters free. 10 meter is obviously expensive, you have to purchase it. And see, if you download 10 meter DM, see the ponds, you can easily identify it. So at the pond it is flat because that elevation of water is always flat. So in DM also it's showing a flat region. Okay. This is the land use. So till now you were seeing land use for the coarse resolution. Now this is a land use of detailed data. So this is a land use data we generated from 12 centimeter satellite imagery. Okay, so it is a France satellite called Virgo or something. I forget the name. Virgo. It is a France satellite, and it is a upgradation of Spot 1. There is a satellite called Spot 1. There is an upgradation version of that. And in Raipur city, we delineated all shops, households, commercial buildings, non-commercial building, public usage building, something like that. So we had a land use parcel, we have a storm facility. For that particular pilot study area, we tried to collect all the data we are having in the field. So it took us to 2 years to just to take pilot study area, okay, including this department. Obviously, we cannot do it alone. So with the department, we collected the data, and then we tried to model it. So this is a slope map. Skipping. This is the SWM process semantic. So there was a hydrological process behind it. So I'm not explaining it here. Okay. Here. So this was the beauty of DM. You can see here 4 images. First is pre-development. At the next, you can see 2D model. Okay. So the 2D model is comprises of mesh, wide mesh. So if you have a fine resolution DM, you can create a 3D mesh. It is something like a triangulation. Okay. So because you wanted to calculate flow from upstream to downstream, so your flow is not only happening in the river, it is also in the fields. So field has only one polygon, so computer will not able to understand how the system will put rainfall data in the polygon, and it will reach to here, the lag time. So the lag time will be calculated doing something like that. So we have to create a small pixel-based analysis to compute your rainfall runoff from upstream to the downstream. Okay. So in the PCSWIM, the PCSWIM model, they have this finite element method already inbuilt. So you just need to put your wire mesh frame. You just need to let system know that what is the subcatchment area, and you have to put some synthetic rainfall. So at the left side, you can see we have 3 subcatchments here, and for post development we have 51, rain gauge 1, because there is very small area, near about 14 square kilometers. So we have just used 1 rain gauge station. So number of conducts means the flow where it going to happen. So in this case it is Nala, but in this case it is urban storm water. Injection is 532. These are the model parameters. So when we started simulating it, we were in a need of a synthetic rainfall, because the historical rainfall which was happened, we had it, we use it for calibration, model calibration, and reducing the uncertainties. But the later we need that IDF values. I think you are aware with IDF. It is an intensity, duration, frequency curve. So if you have a lot of historical rainfall events, you can project few of the events for different return periods. It's called 2-year return period, 3-year, 4-year. Usually we in hydrology we do 2-year, 5-year, 10-year, 25-year, 50-year, and 100 years. So in this analysis, you can see there is a lot of periods we have used. So this is the first initial simulation of observed versus simulated result of our pilot area, and this was the check. This obviously calibration checks. This image clearly shows that this is a pre-development scenario, and that is a post-development scenario. So you have this 2 graphs of hydrograph of 10-year return period and 15-year return period. So 10-year return period graph shows that rainfall peak will go up to 1.6 meter cube per second. But if you see the post development, it is going up to 45. What does it mean? It means that occurrence of runoff or discharge in the basin is quite high right now. So before development, there was no flood. Obviously, see, there is no flood condition, but now the runoff has been increased. Actually, it is discharge. It's not runoff. It is discharge. I should say discharge. So runoff here is coming near about 2, but now it's coming in 1. So 1 hour lag before the flood will generate. So this always happen in urban area. If you correlate your hydrographs for urban area for pre-scenario and post-scenario, you always see thing like that situation. So this situation arises, and we were trying to investigate how severe was that, and we came to conclusion also that this much water is coming extra, and we need to regulate it, and we have to remove it from the catchment. So for that, we did simulations. At the right side, you can see that simulation of this water profiles for each and every nodes for 147, and the left side is showing flood inundations. So the red patches are flood volume of water, which is coming outside of stormwater drains. So flood inundation map for 10-year return period, flood inundation map for 15-year return period. There is no much change, but when we go 100-year return period, it is drastically very high. But in India, we had a regulation from Government of India, Regulation Act from CWC, that return period calculation for stormwater facility is always being taken between 2 to 10 years, even not more than that. So the top, the figure, this figure is being used by the department for, obviously they're not just ready to use it because they need to do it for whole city. So we have already given the idea that how you can do it. Now it is their call that how they can do it. We prioritize some area also. That colorful area right side you can see is the area showing you need to see this one first, then this one, then this one. So based upon the intensity, we plot this scenario maps, and this was the node, the plotted node of flooding. So here you can see there is no flood, no flood, no flood, but this is a full flooding condition. There's 3 graphs. So likewise, we did analysis. So this is how remote sensing data, especially TM, is being used for water resources engineers since very long actually. But nowadays we have fine resolution data like 10 meter, 2 meter, 3 meter. Even at the later of my presentation, I have a beautiful data for you, and you can able to appreciate it that we are able to generate 20 centimeter DM. Can you imagine 20 centimeter DM? How big the data is, and we need a lot of graphical GPU processing unit to use that. I will show at the end of my presentation. So this map was given to the department to investigate further that how they can mitigate those areas, because they were only known about, okay, this area is flooding, but they were not known about how much was the flood volume and how long it will stay in the catchment. This was done by us. So this kind of project, even as a case study and being a professor, you can use it in your area of interest. Those same map has been able to show. See, this is 10-year rainfall, synthetic rainfall. This is 50-year synthetic rainfall we designed. Yeah, at the later. So once you got the idea that, okay, this is a flooding, this is a causing, what you will do? So this is a bonus for you because we use PCSV model. So there are some LID facility. LID means low impact development. So there are 6 by default LID facility you can provide in your study area or the problematic area, issue area, and you can again resimulate it, and you can get it how much flood you can reduce. Means without doing any construction in the site, you can just use any one of the 6 in your study area based upon the land use. But obviously you cannot put infiltration trench in the built up city. Obviously it can only be provided outside the city. So there are a lot of options available. So one of my students, she used this LID techniques to reduce the flood in Raipur city, and we provide this data to the department. And at the later, we also survey this because when we were doing this project, we has a less fund. So there was a company called GIZ, it's the German Academic Action Service and technical service provider to German government, which has a collaboration with our Indian HUDCO project. It is a house urban design or something called. So they have collaborated each other. They came to Raipur and they investigated with us that how this can be managed. So they are more interested to map slum area and working on slum area. So our pilot study area has 2 slums, unregistered, unofficial slums. So we did a project pilot study here, and it's been still being running from the department. So this is the GIS map that you can prepare in your ArcGIS or any QGIS software. Now, this one is the last small case study, which is not being conducted in Raipur, but this is conducted in all over Mahanadi. I intentionally put this because in GIS you can able to see what you can do. Okay, so we had a lot of pollution problem in Mahanadi River. So we had a big Mahanadi catchment in our state. The 60% of area is covered by Mahanadi catchment. So we try to take some pollution samples from this locations. This is the catchment of Mahanadi. This is the natural drains, and these are the points where we took this small samples, water quality samples. So we were actually looking for 7 samples, I guess. Yeah, 7 samples, and we statistically investigated and we prepared a GIS map. And when we gave this to a department, this was also a requirement of department that how they can manage their river water quality. So first of all, how one can get the river water quality map? This was the question. So we were the first who designed this river water quality map along with Ms. Preeti Rajput, Professor Preeti Rajput madam in GC Bilaspur. She was working with us in this, and she was the major contributor in this project. So we collected the sample and we provided her, and she used this methodology to prepare those maps. These are the maps actually. So there was a TC map, nitrate map, dissolved oxygen, pH, conductivity, water temperature, and biological oxygen demand. So the idea behind preparing those maps is basically on the river, not in and around it, because we are measuring water quality in the river. So we were trying to interpolate. This is a what I can say. This is a maximum use of GIS we did. Okay, it's not remote sensing. It's about GIS data analysis. So we had the point data and we wanted to convert it in the river trench. So first we extract river width from the satellite imagery, and after the extraction of those river sections, we try to interpolate our water quality data on the river. Okay, and later we get this. So it has a huge methodology and computation, and I cannot show in the one presentation. So this was the map we finally get. The water quality has been changing from 1.46 to 3.25. So there is a water quality index called NSF, National Sanitation Foundation Water Quality Index we have used, and we get this results. So it is changing from good to extremely bad. And this was the scenario we prepared, and we gave it to the department so that they can take appropriate measures in this catchment. Okay. Yeah, so those were 5 case study that I wanted to contribute you, because you have already been known about the GIS data, remote sensing data, and these are the application that you can apply in your case studies. Okay, later I will provide the presentation, a copy of presentation in PDF, and you can read it carefully and you can go through it because it all has a methodology, so you can directly apply it. Okay. Now coming into advanced remote sensing data. So I think in your past presentation, we have gone through digital elevation model, digital surface model, digital terrain model. I will differentiate here what are those, and also I will tell you how that UAV, it is not a drone, it is UAV, unmanned aerial vehicle, okay, has been using in this water management domain. So this whole project was chaired by our Dr. Professor Dr. M.K. Verma. He's the Honorable Vice Chancellor, CSVTU Bhilai. And in particular, I am the leading the project, but there are a lot of good hands behind me who is working in this, okay, because it's not single man job. So you would see this. So there is 3 level 1 products that we are getting from UAV mapping. Okay. So at many times I will say UAV mapping or UAV survey or aerial mapping or aerial survey. It is same. Okay. So what we usually do, we survey from the UAV. Okay. So right now in India, you you will not get freely UAV data. But sooner or later, after 2 or 3 years, the Survey of India is going to provide all over the globe survey data of UAV, because in US or in Australia, Canada, they have all UAV data of their country except India, because we still have a not prepared regulation for drone fly. You cannot fly drone at any place. Okay, you have to take permission from Civil Aviation, Ministry of Civil Aviation. So there are a lot of work behind it, but soon you will be going to get it. That's why I am telling you, if you are going to do UAV survey or downloading UAV data, you are going to get three things. First is image, orthomosaic image. The reason why it is called orthomosaic image is we are going to get a photograph, single photograph. You have to stick it. आपको उसको एक दूसरे के साथ स्टिच करना होगा, ठीक है? You have to stitch it. So for stitching, there are a lot of softwares available. You can do it. The software will do it for you. Now the second point is DSM, digital surface model. So digital surface model representing the surface elevation of Earth surface. So please mind it, when I'm saying DSM is representing surface of Earth and DTM is representing the terrain of Earth. Okay, that is only terrain, not the building, not the trees, not the highly elevated lands. Okay, so after UAV mapping or aerial mapping, we are going to get these three data sets. Okay, this is the image from our UAV. It is a 5 centimeter high resolution image of CSVTU Bhilai campus, Chhattisgarh Swami Vivekananda Technical Vishwavidyalaya Bhilai campus. Okay, so its campus is still growing, but you can see this is an image, and this is the two products, DSM and DTM. Now you can understand what is DSM. In DSM, you can see all the altitudinal information at the left from 2003 to 2018. So this data is from MSL, mean sea level. At the right side, there is no surface information. This is the information of terrain. So the top side will be used by water resource department usually, and the bottom is done by works department. So if you want to calculate cutting and filling for roads, canals, and designing of a stormwater facility, you are going to use bottom image. Okay, but if you are an engineer of transport, an engineer of flood to mitigate flooding, or of engineer of mostly those are being used by transportation engineers. The first one was okay, because here you will able to get the height of buildings. So if you want to calculate route path mapping, that is applicable. If you want to calculate flood volume, that your first image is applicable. Okay, so this is a comparison of DSM and DTM. You are also getting the DSM DTM from satellite also, that is available. You can go to USGS website in Earth Explorer and you can able to download DSM and DTM. There is a product called Terra DTM and Terra DM, something like that. Okay, just Google it and you can able to download it. So these two images are very good to analyze or model hydrological scenarios, also for transportation discipline. So these are the key features of our VTOL. This is called vertical takeoff and landing UAV, and it has a 60-minute of one flight. In 16 minutes, it captures 1,000 hectares of area. Just imagine how fast when it started doing survey. And the accuracy is 5 centimeters. So think the ground accuracy is 5 centimeter and vertical accuracy is 10 centimeter. So such data is very difficult to handle also. So its cruising speed is 60 to 70 kilometer per hour. So before further going, I need a small pause and I would like to show you a video. Sir, can you able to see this video exploring?
No, sir.
Okay. Now?
Still not. Okay. Now.
Okay. Okay.
Yes.
So this is a small demonstration of our VTOL UAV. So after seeing this, you will able to understand how we are utilizing it. So this is our VTOL, vertical takeoff and landing, and cruising in the horizontal direction. I think you will not get into this volume.
Yes, the volume is not there.
This is the vertical takeoff. So we are having vertical takeoff using programming for things. And
Sir, you are not audible.
So this is a kind of roving. It's done. It's taking image like this. And later it will again land. I will just forward it. Okay. So my presentation is visible right now. Ma'am, PPT is available here, right?
Yes, sir.
Okay. So the reason behind why I show you that we are the only one institute, even one organization in India who is having such good capabilities with this UAV facility in Central India. So we are working for all around the Indian Works Department, for Haryana, for Mizoram, for Maharashtra, and obviously for Chhattisgarh. So we are doing this aerial mapping for forest, water resources department, and obviously all works department who need satellite imagery. So it has a 42 megapixel camera. So it's not like a small mobile camera. It has a big, giant 2 kg stabilized mirrorless camera of 42 megapixel who can see ground from 1 kilometer above the land and able to capture images in every 1 second. So it has good survey capabilities. So I will compare it why UAV technology and why remote sensing, why UAV in remote sensing is very important, and why one should has a good knowledge of that also. So if you see normal satellite imagery from Google Earth, you can see this. This is the image of Talpuri twin city in Bhilai area. There is a small township and they have this oxyzones, the small oxygen. So it has 50 centimeter spatial resolution from Google Earth. And now you can see this is our image, 5 centimeter spatial resolution. Now you can see the information, the detail of information, because we are on the internet, means we are connected through wireless internet. I think you cannot see clearly, but when I give you PPT, you can able to see even transmission lines. So from UAV, you can also capture transmission lines. Okay. This is also an image from Google Earth of a road. And now see, that same road has been surveyed from. Hello. Okay. So we usually use this for boundary demarcation. So there are a lot of application of UAV that I will discuss here. So we are using it for boundary demarcation of forest area, boundary demarcation of individual households for taxation, because government need to reanalyze the data that how much tax should one should pay. So we are doing this boundary demarcation. Then this also helps for distance measurement, the measurement of road, measurement of encroachment area. And presently, just 2 days before, I received one request from ENC Water Resources Department for analyzing and UAV survey of Mahanadi River Basin near to Hirakund Dam, because we had a lot of issue with this Odisha Chhattisgarh border. Because of this dam, we received flooding in the recent August. This monsoon, we got flooded in upstream area of Hirakund Dam. So we are going to map it. Basically, they need this flooded area inundation map, that how much area gets flooded. So we will do it. So this is the accuracy. You cannot able to see trees, small gardens, potholes, and building index from satellite imagery. Not easily. In that case, you have to buy image and you have to stack it. That's again very expensive, very time taking. But with the UAV, you can fly it on your specific area of interest and you can use it. This is we do construction progress monitoring in our campus. So the top image, it was 22 August 2019. Now our campus is building. So second image is 13 January and the third image is for 6 June. So this is also one of the application which is being used by industry, that how construction site will be monitored. Okay. Still L&T is doing with this Landsat and Indian satellite data, but it can be done with the UAV. Okay. This is the contour maps. You can generate contour of 25 centimeters. Imagine 25 centimeter contour. You can do anything with that. You can optimize that digging, filling, a lot of things. This is again one survey data from Bilaspur city, Bilaspur agricultural lands. There is a area called Masturi block. So we did survey and I just plotted for you. See the cross section at the bottom X. Yes. So the cross section, you can understand there is a canal. Okay. So this is a 0.5 meter resolution data. So 0.5 meter resolution data means you can easily track anything in the field. So this project is done for underground pipe irrigation survey. This one is also from Shivnath River. So we did perform one aerial mapping and we started this this is also asked by Water Resources Department to compute cross sections so that they can use it for their projects. So this was the data that you can also do it with the satellite imagery, basically DM. Okay, you can download your DM. For the big rivers, you can do it for the big rivers, which has a width of 1 kilometer or more than 800-900 meters. But if you want to do it for small rivers like 3 feet, 4 feet, it can't possible, or 1 meter. You need a UAV for that, okay, or a UAV data. That is being, I think after 2 or 3 years, you can able to download that also. So we are also having this application of tree counting. So one can count the trees. Okay, so there are a lot of algorithm available right now because UAV technology is almost booming in all around the globe. So you can able to count trees, tree height determination. There are a lot of applications. These images I intentionally put so that you can see the quality of images. And I understand the quality of images is not showing in your monitor because of this internet connection. But it's okay. This is our ongoing project in Bilaspur. So this was the layout plan of underground pipe irrigation. And now you see, when we deliver such kind of engineering solutions to the department, it's really very appreciable that one can easily put their pipes, plan their irrigation systems. Earlier, it was very difficult. Even people would not be able to get where they should dig and where they should plan for irrigation purposes. So now we are using this technology in our state and also going to use it for Maharashtra soon. So this was the plan. At the background, you can see the survey numbers. This is called cadastral map. So at the background, we put cadastral map so that irrigation department will be knowing which field is irrigating and which field is not irrigating. Okay. So such kind of data is provided by us to the Water Resources Department here locally. We also have some application in Rajasthan. So in Rajasthan, they had a lot of problem with this water harvesting. So they started doing it. They dig a small trench. You can see this is a small structure, this one. Okay. So they made such kind of trenching ponds and water retaining structures. And when the department goes to the Maharashtra, the Rajasthan government, the government says, prove it that you have done it. So they called us and asked us to please map and give it to us so that we can ask our government for compensation. So this was also done by us. This is 25 centimeter contours. You cannot see it here. You need a good system to watch it. Okay, I just zoom it for you. These are check dams. So this kind of small feature cannot be detected by satellite imagery. That's why I'm showing. It also done. It is also a kind of remote sensing, aerial remote sensing with the UAV. Okay. So electrical asset transformation. So a lot of demand was there. Yeah, this image is from Haryana. So Haryana government asked us to demarcate electrical assets transformation, this solar on buildings, this, and also we did one small project in Haryana for mosquito breeding. See, our images are able to capture that the tank above the building is opened or not. See, these are open tanks, and we did a small case study with the IS officer. There was called Rana, the officer called Rana. So he was working with us at that time, and he told us, okay, as a small area, we'll perform an analysis. When we map this data and when we inform the local building holders, close your tanks so that you will get less affected by dengue. So in 2014 there was a lot of dengue issue in Haryana. But when we do this, we quite reduce those dengue effects because this is the reason for dengue. So this was also an application of UAV. So UAV application is lot. So this one is the major application of UAV in Chhattisgarh. So we have a lot of mining resources. We are doing minings all around that state. It's not one. There are 6 or 7 mining prone areas. So this is basically a aerial mapping, 3D aerial mapping for mining area. So we are able to calculate the volume of digging, what was the volume before and what was the volume after. Okay, and resource mapping also for Chhattisgarh state. So we are doing it only in Chhattisgarh because this needs again some official approvals. But in ease of knowledge, you must understand and knowing that 3D mapping can be done. Okay, we are also working with CSEB, Chhattisgarh State Electricity Board. They are having this transmission line connection in Korba. There are coal fields, Korba, and they asked us to model it. So we did it for them so that they can pay compensation to the farmers whose land was occupied during this. So this was our accuracy. I have already told you. We have 5 centimeter, 10 centimeter accuracy, and this was the data we can deliver. The images, the digital surface model, the digital terrain model, and yeah. So I think, thank you. My presentation is almost over, and if anyone has a question, you may ask. Okay. Hello.
Thank you, sir. Thank you so much for this wonderful presentation, and we will go ahead and take some time for questions. So,
Please.
anyone has any question, you can directly ask with the sir.
Hello.
Hello.
If